Hi, my name is Salif Banse. In this short video, I will quickly go through my network project. So this project was built using a simulator software like Packet Tracer. So the aim of the project was to build a LAN, a local area network for a business of approximately 40 employees. The business operates on two different floors. So in each floor, we'll have two different offices with 10 open desks. So the aim of the client was to reduce to reduce the cost and at the same time to have a redundant and reliable network. And to achieve this aim, I will subdivide the overall network in four subnets. So each office basically will be a subnet, and to reduce the cost, I will use wire and wireless connection. So I decided to divide the business in four subnets. So this means so we can manage efficiently the each subnet, because if we create a larger network with many devices, it's going to be hard to find out how to and to solve the issue in the network. But if we have like four network with around 10 device in each network, so it will be easier to manage and resolve the issue when they arise. So, and to build this network, I will use different networking protocols. For example, CIDR, classless interdomain routing, IP addressing, DHCP, RIP version 2, SSH, and HSRP redundancy protocol. So this redundancy protocol is very important. It will allow me to eliminate a single failure point in my overall network. So here we have the final network I will be building. As you can see, we have the two different floors with two different devices. First floor with two office, second floor with two office, and each network. So we have each office, as I said, will be a network: first network, second network, third network, and fourth network. And then I have three routers. These three routers will act as default gateway and connect the four network, and this will allow information to flow from one network to another network. So to make this possible, each router uh, will have RIP version 2 configuration, and this will allow information to flow from one network to another network. And also each router will have the configuration DHCP configuration. This will allow the assignment of IP address to each device in each network automatically. So this is a very important protocol. And also, as you can see, we have the configuration of the HSRP. So this is an important network protocol because it will make my network redundant. It will eliminate single failure point, because this protocol allow me to use a virtual network between two different routers. For example, between router 1 and router 2, we have this virtual router. So for example, information, if this active router B1 will fail, so information will go through B2, and the network will not fail. The overall network will still be working. So this means I have to do the same thing between router B1 and router B3. You can see here the configuration of HSRP, here the virtual IP address, and you can see here as well the virtual IP address between router B2 and router B3. So this will allow information to flow from network 4, for example, to network 1, even when this network B will fail. So the information will go through network it will go through router B2. So these are very important protocol to build this network and to satisfy my client. So I will go back now to the theory. Okay, so here I will quickly go through the theoretical description of the network. So we have the topology. So you can see I use a star simple topology, very simple. And here we have the CIDR IP addressing, and this basically allow me to assign and to find out the more useful and more adapted class of IP address to use for my network. And I decided to have, because I want to have 8 network, because I want to create a scalable network, so a network that can shrink according to the business need. I will start from 8 networks. 4 will be used for the current 4 office, and then the other 4 will be used for business uh, needs. So I will use IP version 4 for the network, and I will use, as I said before, the CIDR notation. And the CIDR notation will allow me to borrow 3 bit from the host portion to create 8 subnet with a maximum of 30 devices in each subnet. So below you can see the process I follow to decide the IP address to use for my network, the overall network. So I will start from an IP, a class C IP address, so this, and a subnet mask, this. So this will be my starting IP address value and the subnet mask value. So from there, I will follow um, the method of Wallace. So basically, this will allow me to borrow 2 bits, and if I borrow 2 bit, so I will create a network with I will create 8 subnets. I will create 8 subnets, and as you can see, we can, if I go down, you can see how this is done. So the process I follow to design this network, and at the end, I will generate this important table. So this will show this table is just basically showing the network ID, the subnet mask, and the host range, and the number of hosts in each subnet, and the broadcast ID as well. Very important, because this will allow to identify the device. So when each device want to communicate with each other, so they will send a broadcast message, and this will allow information to, so the routers will allow information to go through just inside the network they are in, and this will make the network more efficient, because information will not go through the overall network, but it will go through only in through the device in the same network. And the job of the router is to take the information from one network to another network when device in different network are trying to communicate. So this is a very important, and so these are the all IP address. So this, I will not use this for the current network, so this, I will use them for the business feature needs. Okay, and here you can see the picture of the network and the configuration. So we have the configuration here, configuration, serial configuration. We have a wire configuration, wireless configuration, using a different type of serial. For example, here I'm using DTE cable. I'm using DTE cable for the serial connection, and then I'm using fast internet here, and this one is just a wireless connection. For the wire connection, I'm using fast internet connection. So, and then we have the DHCP configuration to assign IP address automatically to device in each network. So, and this is how this works. And then we have the SSH configuration. SSH is an encryption protocol that protects a network and allow device to communicate through secure channel by monitoring data transfer and encrypting data as well. So by configuring SSH, so this will allow me to control each router remotely, and because the information is encrypted, so this will allow an efficient and reliable system, network system. And we can see here how this is done in practice inside the command line interface. And so this is how I after configuring the HSS in the router B2. So I can, I use the device, for example PC4, to access, because without configuring SSH before in the router you cannot access. After configuring SSH in the router, you can access using different device. In this case I'm using PC24 to access to the router, and you can see here from the desktop. So from the desktop of the PC4 I access the B2, the router B2, and I can go through some configuration. And then we have the RIP, another important protocol, because this is very important, because it will allow me to ensure that information will go through from one network to another network. So RIP is the routing information protocol, is a dynamic distance vector routing protocol that routers use to transfer information from one network to another network, and exchanging routing table information every 30 seconds. There are two versions. We have RIP2, RIP version 2, and RIP version 1. So for this project, I will use RIP version 2, that is more flexible, and it support IP address and IP version 4 and authentication as well. So and also support multicasting variable length, and I believe this is the right choice for this project. So this is the RIP configuration, and the RIP configuration for router B1 RIP configuration. So as you can see, so RIP was configured in each of these routers, this one and this one. This will allow information to flow from one network to another network. This router will act as a default gateway for my network. So after the router configuration in B2, we go for router configuration, the RIP configuration in B3, in router B3, and then we have the configuration of one of the most important routing protocol, so the HSRP configuration. So the HSRP is a dynamic host configuration routing protocol, is a redundant protocol property of Cisco that allow to create a virtual gateway IP address between two or more routers, and use one router as active and another as a standby router. The active router will transfer data in a normal condition, but if for example for some reason the active router fail, so the standby router will become active, and this will allow the network to keep exchanging information, and this will eliminate single failure point. So here is how this simple protocol works. Basically, between two different routers, we need to have a virtual IP address, and we set one of these routers to be active. And if for some reason one of these routers fail, so if for some reason, for example, the active router fail, so the standby router will become active, and this will allow information to keep going through the network. And I have to make this possible, I have to do the configuration of the HSRP protocol in each router. For example, between router B1 and router B2, we have this virtual network. Between router B3 and B1, we have this virtual network. So for example, B3 can be active, and if for some reason this B3 go down, so information will go through B1. And if we are here in this network 4, if for some reason, so this B2 will go down, information will go through B3, because we have SHRP configuration here, like the virtual router, the virtual IP address is going to be this, and this will allow this network to exchange, to have the opportunity to choose two different options, and it will choose the one with less cost. Okay, so this is how this protocol was configured on my three uh, routers. So okay, b3 configuration, b2, and then b3, and then here, so this is the verification section. So this PDF will be available as well on my website for further details. Okay, okay, okay. So now for demonstration, I will try to send so try to ping from the network 2 to network 4, and see if the ping will be successful. So basically this will allow me to see if information is going through the two networks, if the device in the two network can actually exchange information. So I will try using the ping command to see if this is possible. So ping, and then I need to pass the IP address 192, for example, dot 168 dot 4.99. So this is one of the IP address in this network 4. So let's see if it's going to be successful. Yes, as you can see, so this was successful, and loss 0. So this means we are getting back a reply. So these two networks are working, so are communicating correctly. So this is happening because of the RIP configuration, and the RIP allow the two network to communicate because information will go through